Okay, today we need to talk about vectors. Okay, so vectors need some kind of notation. First, maybe an idea. So the thing I want you to think about is kind of a force or a push.
What about a pull?
No, I don't want you to think about pulls.
Okay.
Only pushes. So what we're going to think about, right, is you've got some little thing. If you want to push it, I would probably draw that like this, right? Okay. What two components does a push have that are interesting?
Direction. Amount and strength, kind of?
Yeah. A direction and
Where did you say the 10 poles would be?
probably in the closet. Where we used to keep the whiteboard to go outside.
Like lows, safes in there, with like flags. I didn't see any 10. I could look again.
No worries. It's cool. We don't need them that bad. Okay. A direction and okay. What's a magnitude?
In this case, the length.
Is it kind of just like a measurement of power to an extent?
Yeah, exactly. So we just needed a word for like the concept of how hard you're pushing, right? So we need a direction in which you're pushing and a concept for how hard is that push. So we're going to call that magnitude. I'm going to add some words here that I'm going to use occasionally. I'm going to probably say length once in a while. It's possible that I'll say norm occasionally. All of those things just mean the length of the vector or the amount you're pushing. You guys all good with that? Okay. I'm going to put down a list of operations here. I don't want to get super tangled up right now in what these are. So I'm just going to do ideas quick. And then we'll talk about exact definitions as we go. So the first two that should be pretty easy are one called scalar multiplication. And I'm going to need to tell you what a scalar is probably. And the other one that should be pretty intuitive is addition. Let me start with addition. Let me add the other two. And the other two are going to be a dot product and a cross product. Have you guys had a little bit of vectors before?
Yeah.
Show of hands for anybody who has not had vectors. Okay, there's a couple. All right, so dot product and cross product are a little bit like the idea of multiplication, except they're not multiplication. It should be noted that there isn't a convenient way to define multiplication for vectors, so let's not sweat it, okay? You guys all hear that? What was the thing I just said about multiplication? Yeah, don't sweat it because there isn't one. These two things look a little bit like multiplication, but they're not. A place where you can multiply vectors is extremely special. Okay? Most of the places we're going to live don't have them. Cool? All right, let's do addition quick. So here's a push, and here's another push. What would it mean to add pushes together?
Do one to the other, kind of?
Yeah, that seems like a good way to do it. Okay, so if I'm going to do this, right, I'm going to take this push and add that push. The way I'm going to do that is I'm going to do that push. And then, yeah, and then I'm going to put the other push on the tail. Or on the tip. You guys see that? So where's the result here? So it starts where you started, right? And ends where you end. Congratulations, you all are awesome at adding vectors already. Do not get tangled up in this. It's not that hard, right? You just put them tip to tail, right? So you just pile them up. If you've got a bunch of vectors, right, that you're adding together, continue, right? Does it matter which order you do this in?
No.
Are you sure?
Not addition.
Probably not. Not addition. So if I did the other way, right, I would start at the same starting point. I would do the little kind of short down vector, and then I would do this kind of long. And you guys see I end up in the same place? Okay, that's maybe not necessarily totally obvious, but it is true. Okay. I should probably get some notation here. So notationally, I'm going to say I've got a vector u. So this little thing here, right, is a delimiter for vector. I'm noting, right, that a shape or a symbol is a vector when I write this little hat over the top of it, right? On tests or in your book, those will be bold usually. Meaning the letter will be bold, it doesn't usually include the little vector hat. You guys cool with that? If you are not sure if a letter is bolded on the exam, ask, and I will gladly tell you. Cool? So if I have a vector u plus a vector v, what would I call the blue vector?
Vector u plus vector u.
Excellent. U plus v. Be good with this? I'm hoping this is not a surprise notationally. It maybe would be more honest if I did this thing, right? If I did u plus v with a big vector thing. But that gets confusing fast, so just know. Cool? All right. Let me ask you the dumbest possible question. What would I mean if I wrote 2u?
You added twice.
That seems reasonable, right? I would probably like to think about that as u plus u. Okay. What else could I define this way?
That's a scalar.
Oh, what's a scalar now?
You're multiplying a vector by something.
Yeah, multiplying a vector by whatever the heck a scalar is, right?
Scalar is just a constant.
Yeah, a scalar is just a number out of somewhere. So I'm being a little bit flip with this thing, right? For us, we're going to think about scalars as being numbers in the reals. Okay? So I think I have an intuitive understanding of what 2u should be. But what the heck would like pi u be?
U 3.14 times, which is a little off. It's not. It's a bit more direct than that.
Yeah, okay, but things should just be magnitudes and directions, right? Like that was my idea. So
It's an increase.
The direction doesn't change.
on this guy, I'm going to say direction, right? Should be along u, right? But the magnitude is what?
Pi times u.
Pi times magnitude of u, right? You guys all see that? This brings me to a new thing that I ought to be talking about, which is what? Yeah, I probably need to figure out a way to denote magnitude. Okay? So, I should probably take u, right? And then put some decoration on this to talk about the magnitude?
It's kind of like an absolute value, but for distance.
Yeah, right? It should be like an absolute value thing. You guys see that? Why should it be like an absolute value thing?
Just if you're going to the other function,
Yeah, the magnitude should be positive, right? It should be the length of this thing, which is a little bit like the absolute value of a number, right? It just tells you how far from 0 it is. This is just going to tell me how far the tip of this thing is from the tail. You guys all see that? So it should feel like an absolute value, but it's not. So how do you soup up the absolute value bars to make them work on vectors?
They're brackets, right? Weren't they brackets in your textbook? Or is that for some?
They're close. Yeah. Just soup them up. Like, just make them better. Like, add some oomph to them. So that's all this thing is. So this thing is the magnitude of u. That's all good with that?
No, me? No.
And I haven't told you how to do any of this crap with vectors, right? Like, I've said that these are things that we can do with vectors, but you guys still don't have an example of what a vector is other than arrows on the board, right? Okay, so maybe we should throw this into 3 dimensions and add some coordinates and stuff and talk about how to actually calculate. You guys good with that? Okay, so this was the general idea, then let's do specific.